Okay, good morning, everybody. Any comments on the exam before we start? Do you guys like the exam or not like the exam? Yeah,
It was okay.
it was okay.
The one with the HMX, like when you had to figure out if you were using sub or not.
Figure out whether you're using USub for the, yeah.
I think it was like the last question. That was the one, I think it was like the third one. So
Uh-huh. Yeah.
threw me off a little bit.
I got a lot of student emails about problem number 4 regarding the quartic polynomial x to the 4 minus b to the 4. Okay. That wasn't supposed to be outside of the range of capability, but seems like maybe I should. I'll tell you what, I'll talk about it on Friday, because there's still 1 or 2 students that haven't turned in their exam for various reasons. So, but I think really the main issue there was that people had a difficulty distinguishing between what is a variable and what is a constant. And a variable is, it can take values, but it can take multiple values, whereas b, some constant, can only take one possible value. Okay, so for example, the other time where you play with variables and constants is when you have the equation ax squared plus bx plus c equals 0. When you guys saw this quadratic equation in high school probably, you guys know that these x's here, those are variables, right? But these a, b, and c, we just write them in the place of where we would have just one number. And generally, they're only ever going to take one value. Okay, so, and we had that if we wanted to solve this equation, we know that x is going to be equal to, negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? And we're writing all these letters here, but not because they are, this isn't a function here where we get x by taking random values of b and a and c. We know in general that a, b, and c are some number, we just might not know what that number is yet. So if I told you that x equals 2 and a equals 3 and c equals negative 1, well, you'd be able to use this equation to solve for the constant b, which is just some number. Okay, so a little bit of a distinguishment to be made between what is a variable and what is a constant. So if we were to say, look at the graph of this function, it'll look like some parabola, right? Where all along this thing we have all these points, right? These all have different x values. X can change value, right? X can change value. But what b and a and c are determining are really something more fixed than that. They're determining the shape of the parabola. They're determining how quickly it rises. They're determining how wide it is across. They're determining how high above the x-axis is it. And these are all sort of fixed properties of our parabola. So that's kind of well, my best attempt at an explanation of what is the difference between these two things. Okay. So I'll talk more about that on Friday. What we're going to do today, actually, let me ask before we start, are there any other questions about the exam? Or comments? Okay. Then, yeah, today we're going to talk about average value. It's probably going to be basically the last thing we learn in this class. We're going to spend today and hopefully Friday as well on this, and we'll see. I might incorporate one more topic. Haven't decided yet. One thing that I will tell you is that the Monday class will be asynchronous. Meaning that I'll post something on the YouTube channel and I might give you guys some kind of activity or something like that. But we won't meet in person for that day of class in case you guys want to go home early or something like that. Okay. So that's all. Yeah?
Is there homework due this week?
There is no homework due this week. I think I will give one more homework assignment. It'll probably be due following Thanksgiving break. I think I'll have to make it due on Tuesday or something like that because of the way they do the reading days. You're not supposed to like have things due on like the reading days. They're supposed to be study days for you guys. So it'll have to be on a weird day. But yes, there should be one more homework assignment. I haven't posted it yet. So don't worry about it for now. Other questions? Okay. Then let's jump into the warm-up problem. Let's do these two integrals here. We'll take 3 or 4 minutes to try them out. And then we will learn about average value. Okay, looks like everybody's nearing completion. Anybody need a little more time? Okay, sweet. So we'll do this first one together. It's pretty simple. We just want to find the antiderivative of this thing and then start plugging, right? So antiderivative of 4x cubed, I'll just raise the power by 1 and we'll get x to the 4th, or 4x to the 4th over 4. This over 4 came from dividing by the new power. And I'll subtract. This will be 2x. We'll raise the power by 1 and divide by the new power. And then we will do the same thing on this 1. We can think of 1 as being like 1 times x to the power 0. So we'll make that 1 times x to the power 1. And we'll divide by 1. And we don't need a plus c because we're doing a definite integral here. So we can choose any antiderivative we want. I'm just going to choose the one where c is equal to 0. And we're just going to now plug in 0 and 1. Which one do I plug in first? Yeah, 1. Plug in 1 first. So we'll get 1 minus 2/3 minus 1. We'll put all that in parentheses, and we're going to subtract from that when we plug in 0, but when we plug in 0, we're just going to get 0 minus 0 minus 0, right? So in the end, we should get negative 2/3. Okay, so that's a fairly standard power rule, fundamental theorem of calculus type problem. All right, the next one has a little bit more meat on it. So I'll ask for some help from somebody in the class who wants to help me do this integration here, or help me get started. Ashlyn? Not the derivative, but the antiderivative.
So it'd be ln of x, the absolute value.
Yep, we're going to do ln of the absolute value of x.
And then evaluate that at -1.
Yep. And which one should I plug in first?
E.
Should plug in e first. So let's do ln of e, and then we will subtract ln of 1. Well, if I take the absolute value of e, I just get e, because it's a positive number. And if I do the absolute value of 1, I just get 1, so we can just write it normally. And what is the ln of e? Natural log of e. You know?
1.
Yeah, just 1. And how about the natural log of 1?
0.
0. Perfect. Thank you, Ashlyn. Okay, so agree? Is that how everybody else solved it? Okay, cool. All right, so what we're going to learn about now is the average value of a function. So if f of x is a continuous function on the interval a comma b, where a and b are just numbers, let's see, do we need anything else? No, that should be good. Then the average value of the function f of x on the interval a, b is given by the following formula. 1 over b minus a integral from a to b f of x dx. Okay, so this is how we find the average value of a function. So let me draw some pictures and explain why this makes sense. So say we had some coordinate axes, and we have some function 1 and 2. So if we have some function which is, for the first unit, the value of the function is 1, and then for the second unit, the value of the function is 2. Then, half of the time, our function value is 1, and half of the time, our function value is 2. And so we would say, for this example, we would say average value of f of x is, what should it be? Half of the time we're 1, half of the time we're 2. What's the average value?
1.5.
Yeah, it should be 1.5. Okay, and the way that we're doing that is by just taking these two, we add them together, and then we divide by 2. Okay, right? Take them together and we add by 2. Okay, but what we're really doing, what this formula is saying, is actually what you can do is you can take the area of these two boxes. This one will have area 2, and this one will have area 1. You add up the area underneath the boxes, and you divide by the length of the interval. That's this b minus a here is exactly the length of the interval here. Okay? So, in our case, we said that the integral from a to b of f of x dx was 3, and we said that b minus a was 2, so we got 3 over 2, which was 1.5. Okay? So that's what it's saying. However, this is kind of a really obvious example, but we can handle more complicated things now, such as what if we had some function which was 1 for a really long time, and then 2 for just a second. Then it becomes a little bit more complicated to find the average value of this function. What we would have to do is split this up into equal intervals, and then we'd have to say, okay, let's see, we would take 1 plus 1 plus 1 plus, my God, how many do I have? 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. And then we take plus 2 and we divide that by 8. Right? That's what we would do to find the average value of that function. Okay? And again, what we're doing is we're just adding up all these areas here. 1, 1, 1, 1, 1, 1, 1, and then 2. And then we divide by basically the number of boxes. Okay? So if we were to have some function, let me move this over a little bit. So now, if we were to have some function like this, and we want to find its average value, well, we can apply this process. This process basically is saying, take the area under the curve and divide by the length of the interval. Well, we know how to find the area under the curve. We could use, for example, Riemann sums. So if we took, instead of this function, if we took the function which looks like this, then we would know how to find the average value of that function by doing the area of all of these boxes and then dividing by the number of boxes, right? And what does that look like? This looks just like a Riemann sum, right? So if we take all of these areas and we divide by the number of boxes that we have, then we're going to get something which is close to the average value of the function we're interested in, because we found the average value of a function which is close to that function, right? It's the function which is just piecewise constant on each of these small, short intervals, right? And it has a bunch of jump discontinuities where it just jumps up or down. Okay, so that's the general idea. Before I erase this, are there any questions about what we're doing? Okay. So let me put a little line here maybe. That was an example. Okay, so now let's do some practice. So if we want to find the average value here for this function, f of x equals 3x plus 5 on the interval 2 comma 5, then what we need to do is, well, we can have a picture if we want. You know, this is not necessary really, but maybe it will help. 3x plus 5 looks like this. And if here's 2 and here's 5, we're interested in understanding the average value of this function between these two goalposts, okay? So it's probably going to be something like right here, right? Kind of halfway up if we have a line. Okay? So this is the average. Okay, so let's actually use our formula here. Well, we have some function, 3x plus 5. It is a continuous function because it's a line. All polynomials, in fact, are going to be continuous functions. So our interval here, a, b, is going to be 2 comma 5. And all we have to do is do 1 over b minus a times the integral from a to b of f of x dx. So that'll be 1 over, now b minus a will be 5 minus 2, times the integral from 2 to 5 of 3x plus 5 dx. Okay, so now all that's left to do is just do this. So we'll take 1/3 times, let's see, 3x will become 3x squared over 2. Do the square brackets. 3x squared over 2 plus 5x. And we will evaluate that at 2 and 5. So we'll take 1/3 times, in here we'll have 75 halves plus 25, and we will subtract from that 12 halves, so 6 plus 5 times 2 is 10. Okay. So I guess we can multiply it out. That's 1/3 times 75 halves plus 50 halves is going to be 125 halves. We'll subtract 1/3 times 16. So we'll get 125 over 6 minus 16/3, something like that. Okay, and what that is just the average value of this pink line in between these two goalposts. Okay, so it's as if I take a whole bunch of points on this line here, and I'm trying to find the average height of all of the points which are in between these two goalposts. Okay, that's what I'm trying to do. I want to take the average value, or the average height, of all of those points. Okay, so it's kind of like if here's me and, you know, I have my hair looks crazy like this or something, and I wanted to find the average hair length on my head, then I would take all of the lengths of the hairs on my head and add them up, and then I would divide that by the number of hairs on my head, and I would get the average length. Okay, that's kind of what we're doing. Kind of a weird example to give, but yeah. Okay, so are there any questions about how we did that problem? This is one of the few things in calculus which I feel like is fairly intuitive. At least it has a really good graphical interpretation, which is nice if you're a visual learner. Okay, so let's try problem number 2 on our own. I'll give you guys 4 minutes. How about 4 minutes? I'll give you 5 minutes if you need it. Okay, it's been about 4 minutes. Let's have a show of hands if you finished the problem. Okay, most people. Anybody like a little bit more time? Okay, there is something challenging about this problem, I think. What's the challenging bit? Or did everybody think it was completely straightforward? There's nothing about this problem that threw you for a loop? Kevin?
I thought finding the antiderivative was kind of hard.
Yeah, finding the antiderivative was kind of hard. Why was it hard? For this function here, finding the antiderivative of the square root of x plus 1. How could we change this to make it way easier? That's my question. It'd be so much easier if this, instead of square root of x plus 1, it said something else. Yeah?
X plus 1 to the 1/2.
X plus 1 to the 1/2, or even easier than that would be just the square root of x, or x to the 1/2. That's one that would be probably easier to do. What I'm trying to get at here is I do want you guys to get in the habit of getting into a problem, and when you get stuck, asking yourself the question, why am I stuck? What is the issue here? And how do I wish this looked? And that will give you some sort of insight into what you might want to be doing. Okay, so in our case, let's draw here. Does anybody know what the graph of square root of x plus 1 looks like? I'll give you a hint. If we have y equals the square root of x plus 1, then we have y squared equals x plus 1. And then x will be equal to y squared minus 1. Does that give you any ideas? If I gave you the equation y equals x squared minus 1, what shape would that have? Yeah, it'd be a parabola, right? So, Yasmin, you have an idea? Like a V?
Like if you were to start at -1 because it's x plus 1 underneath, and then it would kind of just go up.
Yeah, correct. It's gonna be half of a parabola. Okay, and it's gonna start at -1. Okay. Let me get rid of this nonsense. It's gonna start at -1, and it's going to be the positive half of this parabola, which if we drew the bottom, it would look like this. But we don't usually draw the bottom, because if we had a function which was a sideways parabola like this, well, it wouldn't be a function at all, would it? It wouldn't pass the vertical line test. So when we do these square root functions, we really just draw the top half. Okay, we take the top half. So that's what it looks like. And we're asked to find the average value of the function between these two goalposts, 1 and 4. Okay, drawing the picture isn't necessary, but I think that it is sometimes helpful. So we're looking for the average value. I don't know, it looks like maybe it'll be a little bit higher than the halfway point. Something like that. So we want to find that average value there, and what we know we should do is we should take the height of all the hairs in this interval, and we should add them all up and then divide by the number of hairs, except we kind of have an infinite number of hairs. So what we should really do is take the integral from 1 to 4 of f of x dx, and we should divide that by the length of the interval. In other words, I'm going to multiply by the reciprocal. 1 over b minus a, that should be 4 minus 1. And I guess I probably should have replaced f of x dx as well. We'll make it the square root of x plus 1 dx. And now we've got it all set up, and all we have to do now is just solve this problem, which looks like just some number multiplied by some integral, which hopefully we can solve. However, I can't just go ahead and find the antiderivative of this. The reason is I know what the antiderivative is of the square root of x, but I don't know what the antiderivative is of the function square root of x plus 1, okay? That's too complicated for me to do. I don't have a rule for how to do the antiderivative of the square root of another function. So what should I do? Any ideas? What do I do when an integral is too complicated? Yeah, u substitution. What should I choose to be u? Kevin?
X plus 1.
Yeah, x plus 1. I should choose to be u, whatever is kind of giving me issues here. If this, this is what I was kind of saying earlier, was I wish this looked like the square root of x. Or maybe this, not the square root of x, but the square root of u. Then I would know how to do that antiderivative, because it's just a power rule situation. Okay, so that's what I want it to be. So let's do the u substitution, u equals x plus 1. Then what is du going to be? Yeah, 1 dx, or just dx. We'll write 1 dx, and then we'll write 1 times dx, that's just dx. Okay, so my x plus 1 here is going to get replaced by u. And my leftovers are just dx, and they're going to get replaced by just du. So this is going to be 1 over 4 minus 1 times the integral of square root of u du. Now I can use one of two methods for my bounds. I'm going to use, actually, yeah, I'm going to use method 1, I think, where we switch the bounds, okay? So I'm going to take 1 here. I know that's an x value. I'm going to plug it in for x in the function which relates u and x to figure out what it should be as a u value. So if 1 is x, then u equals x plus 1 tells me that u should be 1 plus 1. So this value here should be 2. And then the 4 should become 4 plus 1, which is 5. Now I'm just going to finish out the integral using u. So this will be 1/3 times the square root of u is u to the 1/2 power. If I raise 1/2 by 1, I will get u to the 3/2 power, and then I'll divide by 3/2. And I'll evaluate that at 2 and 5. Dividing by 3/2 is the same as multiplying by 2/3. So this is going to be equal to 2/9 times u to the 3/2 power, evaluated at 5 and 2, equals 2/9, and then in my parentheses, the way I do a 3/2 power is by recognizing that u to the 3/2 is equal to u cubed to the 1/2. Right? If I had a power to a power, I would multiply the powers. So the way I'm going to compute this is just by taking the number 5 and cubing it, and then taking the square root of that number. So if I take 5 and I cube it, I get 125, and then I square root that. I'm going to do the same thing with 2. I'll cube it, I get 8, and then I'll square root that. And that'll be my answer. So I can see how maybe a student might get confused on this problem because the U substitution is almost trivial, right? It's a situation where you might start doing U substitution and then think like, wait a second, du is just dx, what's the point? But there is a point, it's to remove that pesky +1 there, which is really causing us troubles, okay? If we have just this green piece here, this integral of the square root of x plus 1 dx, we don't actually have a rule for how to take the antiderivative of something like that. So we got to switch it into something which is a little bit more rule-friendly first, okay? And now I can actually use this, by the way, to give you a really good graphical interpretation of what is happening with U substitution. Okay, so let me take this and move it up here and remind you that this was the y-axis and this was the x-axis. Well, I can draw this again using the u-axis and the y-axis. So the green integral is expressed in this top thing here, this top graph here. And then the bottom integral, what does that say? Well, it says to do 1/3 times the integral from 2 to 5 of the square root of u du. Well, the way I would graph square root of u would be a little bit different than the way I graph square root of x plus 1. I had that +1 in there, which means I had to move it to the left 1 unit. But square root of u, there's no +1, so it's just going to start right here smack dab at 0. And it's going to go up like this, and it's going to have the same exact shape, but it's going to be moved over a little bit. And what this u substitution is really saying is that if we want to find the average value of this top function between these two red goalposts, well, we can just move the whole function over and do a different problem. Instead of moving from 1 to 4, we'll move from 2 to 5. And we'll find the average value of this function, which is a little bit more convenient between these two goalposts. So we just kind of took the entire thing, goalposts, function, and all, and moved it over 1 unit. That's really what the u substitution was to do, okay? So it's kind of like in calculus, we're always trying to take problems which we don't know how to do or problems which are difficult and turn them into problems which we do know how to do, or problems which are easier, at least, right? So that's really what we're doing here. We're saying, I don't want to find the average value of this weird function between these two goalposts. I want to find the average value of a function which is just like it but slightly nicer between two equivalent goalposts. That's really what the u substitution is doing. Okay. Are there any questions about how I did this problem? Can I get an honest answer from the class? Did u substitution occur to everybody who did this problem? Let's have a show of hands if u substitution occurred to you. Okay, thank you for being honest. There's not too many people. So how did you do the problem then? Maybe there is another way to do it and I just don't know of it. X to the 1/2, x plus 1 to the 1/2. I'm pretty sure u substitution is necessary for this problem. Yeah, it's definitely necessary. Okay, so yeah, maybe I should talk for a second then about when the sorts of antiderivatives that we know how to do. Let's add an extra page. Oh, well, we're almost out of time. We know how to do basically three things. We know how to do integral of like x to the p, where p is some number. We know how to do integral of e to the kx. K is some number. And we know how to do integral of 1 over x. If we have a problem that doesn't look like one of these three things, we need to use u substitution. Okay? U substitution is needed for something like f of x to the p dx, where f of x is a function and p is a power. So this is the category that our problem fell into. We had the function x plus 1 being taken to the power 1/2. So we needed u substitution. We need u substitution for things like e to the f of x dx, and for things like 1 over f of x dx, or things like integral of f of x times g of x dx. Sometimes they look like that. Okay, so if we don't have a really simple problem like one of these guys here, we're going to need to use u substitution. Okay? All right, that's all for today. Thank you. See you on Friday. We'll do more average value stuff on Friday.
The test.
Sorry?
I had a question about the test.
Oh, yeah, I got your email about it. No problem, by the way.
Okay. I realized I went back and read through on Blackboard and they said submit it by Blackboard. And I said,
Yeah,
oh my gosh.
I meant to email you about that. Yeah, sorry. Yeah, that's totally fine.
Are you
Don't
sure?
worry.
Okay.
Yeah.
I submitted it through both.
Yeah, I as long as I get it on time, that's fine.
Okay,
Yeah.
awesome. Thank you.